In a global economy, supply chain management is the key to a company's success in economic competitiveness, time, and service quality. Therefore, the optimization of supply chain network design is crucial to corporate competitiveness. It involves multiple disciplines and directly affects logistic efficiency and costs. The problem of carbon emissions in logistics is prominent, bringing many adverse effects. Green and sustainable development logistics has emerged. By optimizing the design of supply chain networks, carbon emissions can be reduced and win-win economic, social, and environmental benefits can be achieved.
What I want to discuss is the problem statement and research problem of this study. It includes three parts: introduction of research problem, core problem of this research, and the research purpose. With global climate change, the logistics industry is under great pressure to reduce emissions. This study mainly discusses how to reduce carbon emissions and achieve green sustainable development in logistics process by optimizing supply chain network design. This study discussed the development paths of low carbon logistics and the win-win situation of economic and environmental benefits through optimizing supply chain network design to meet logistics efficiency while reducing carbon emissions. The main research purpose of this paper is to provide theoretical support and reference for the society to reduce carbon emissions in the logistics process, and to provide methods and suggestions for enterprises to optimizing supply chain network design. Then I will talk about literature review and theoretical framework. In order to study how to optimize the network design of supply chain to achieve the purpose of reducing carbon emissions, this paper studies the theoretical framework of 10 literatures and critically analyzes their theoretical frameworks. Many literature have proposed methods and theories for low carbon logistics, and combined with their advantages and disadvantages. This study puts forward its own theoretical framework. The theoretical framework of this study uses policy-driven, market demand, and technological progress as three driving factors to promote the optimization of supply chain network design, which in turn positively influences green logistics projects, which promotes our central variable of carbon emission reduction and green performance improvement. Finally, three outcome variables are output, environmental benefits, social benefits, and economic benefit.
This study concludes that through the optimal design of supply chain network, the practice of green logistics can be effectively reduce logistic carbon emissions and achieve significant results in green and sustainable development. This study is similar and verifies the positive effect of optimizing supply chain network design on reducing carbon emissions, which is consistent with the conclusion of previous studies. However, in terms of differences, this study combines the optimization of three major driving factors: policy, market demand, and technological progress, which is more comprehensive and systematic. more conducive to timely, dynamic adjustments, and the proposed optimization methods are more specific. At the same time, research results have limitations and may be affected by uncontrollable factors, such as policies and markets during implementation. The introduction of new technologies will increase costs and bring certain risks to enterprises.
In order to promote enterprises to optimize supply chain network, this paper put forward 3 suggestions. First of all, the state can introduce low-carbon policies and regulations, requiring enterprises to reduce carbon emissions in the logistics process, so as to promote enterprises to adopt low-carbon environmental protection design. At the same time, incentives can be introduced to subsidize enterprises that actively adopt green design. Second, strengthen the concept of customer sustainability, raise environmental awareness, use healthy green products, be willing to support product using recycled or renewable materials, and provide service in a low-carbon operating model. Finally, stimulate the innovation ability of enterprises, create more green logistics methods, such as new energy vehicles or more efficient and convenient management system, such as intelligence logistics systems, effectively reduce logistics cost, improve service quality, optimize the supply chain network, and promote the long-term stable development of the logistics industry. In the optimization design of enterprise supply chain network, enterprises can optimize the design from 3 aspects: location, transportation, and inventory. First, when considering the location of facilities, companies can place facilities such as warehouses and distribution centers closer to suppliers and customers, reducing transportation distance. And at the same time, the sites can also be located near low-emission transportation or new energy networks. Secondly, in terms of transport, we can optimize route planning using advanced route planning software, taking into account vehicle loading rates and traffic conditions to design the most energy efficient transport routes and reduce unnecessary carbon emissions. Multimodal transport can also be used to combine road, rail, water, and other modes of transport to give full play to their respective advantages and reduce carbon emissions during transport. In terms of inventory, the integration of logistics facilities, the integration of scattered small storage facility into large integrated logistics centers through centralized distribution to reduce unnecessary inventory turnover, reduce energy waste and high carbon emissions. Green logistics is an inevitable trend in the development of logistics industry. This paper mainly studies how to optimize the supply chain network, design and reduce the carbon emission in the logistics process. This study seeks literatures and combine their advantages from different scholars' theoretical frameworks on green logistics, fills some gaps in theoretical frameworks, and summarize its own set of theoretical frameworks in order to achieve the goal of reduce carbon emissions and improving green performance. Through technological innovation, policy support, and social concerns, green logistics has achieved remarkable results in the upgrading of transport vehicles, the optimization of warehouse management, and the integration of multimodal transport. But green logistics still face many challenges. First of all, the initial investment in the development of green logistics requires the purchase of new technique, equipment, and the construction of green logistics system, including the increase the latter operating cost, the need to maintain equipment, and energy cost, such as battery maintenance and the replacement of new energy vehicles. Secondly, the technology of clean energy is not mature, and the stability of new energy still needs to be further improved, and the complexity of information technology management and the system integration is difficult. Finally, although customers' awareness of environmental protection has increased, some customers still attach importance to price rather than green value, and building green brands need to face more cost pressure and market price competition than peers. In the future, green logistics will develop in the direction of low carbon, intelligent, and global collaboration and of the whole chain. Through the joint effort of technological progress and society, green logistics can not only promote the logistics industry to achieve sustainable development goals, but also play an important role in global emission reduction and environmental protection, and inject new impetus into the coordinated development of economy and ecology.